Okay, in this question, we have to find the remainder when ax cubed minus 5x squared plus 3x plus 6 is divided by x plus 3. Okay, remember when we have such division, we call ax cubed minus 5x squared plus 3x plus 6 the dividend and x plus 3 the divisor. We're going to solve this problem using long division. But before we do that, let's recap on how we do it for long division for numbers. So let's say we have to find the remainder where 488 is divided by 3. So 488 is the dividend and 3 is the divisor. So I'm going to put 488 under the roof over here and 3 the divisor outside. So the first step, we're going to focus on just the number 4. I'm going to ask ourselves, what is the largest multiple of 3 that is less than or equals to 4? In this case, I'm going to put a 1 over here. Because when 1 is multiplied to 3, I get 3, which is the largest number that is the multiple of 3 and is less than or equals to 4. And the difference will give 1. And when I'm done with this, right, actually I move on to the next number. I'm going to bring 8 down. So the next number I'm going to move on to is 18. So I repeat the same question again. What do I put over here so that when this number is multiplied by 3, I get the largest multiple of 3 that is less than or equals to 18. So in this case, I put 6, because 6 times 3 is 18, and the difference is 0. And repeat the step again. I'm going to bring down the 8. I'm going to focus on 0, 8, the number. In this case, the number I'm going to put here is 2, because 2 times 3 is going to give me 6, and I'm going to get 2 as the difference. Okay, there's no more numbers I can bring down over here. So I ask myself, 2, do I stop here? Because there's no way that I can multiply some number over here to 3 so that I get a number that is less than or equals to 2. So I'm going to stop here because the value over here is smaller than that of the divisor 3. And so we say that the remainder when 488 is divided by 3 is 2. Okay, now let's use this idea for the long division for polynomials. So I'm going to write the roof again. And because ax cubed minus 5x squared plus 3x plus 6 plays the same row as 488, which is the dividend, we're going to put it inside the roof, under the roof. And x plus 3 plays the same row as 3. So we're going to say that x plus 3 is a divisor. I'm going to put it outside the roof. So now the first thing, I'm going to focus on ax cubed. I want to get rid of ax cubed, just like how I got rid of the numbers and move on to other numbers for long division for numbers. So ax cubed, I want to get rid of it. So I ask myself, what do I put over here? So that when I multiply this algebraic term, now it's algebraic term, it's no longer numbers. So algebraic term over here to x plus 3, I can get rid of this ax cubed. So I'm going to put 8x squared. Because when ax squared is multiplied to x plus 3, I get ax cubed plus 24x squared. And just like the case for numbers, I'm going to take the difference. And once I take the difference, I will get rid of ax cubed. I will get rid of ax cubed. So I'm left with negative 29x squared plus 3x. So just now you realize that I didn't actually pay attention to negative 5x squared when I was doing the consideration for this algebraic term over here, because I'm just focusing on ax cubed. I want to get rid of ax cubed. So of course I get some x squared term, which is not surprising. And this is going to be the next thing I'm going to focus on, the negative 29x squared. I'm not going to focus on the plus 3x at the moment. So to get rid of this negative 29x squared, so I have to multiply something here to x plus 3 so that I can get rid of this 29x squared. So in this case, I'm going to consider negative 29x. Negative 29x. Because when negative 29x is multiplied to x plus 3, I get negative 29x squared minus 87x. I'm going to consider the difference again. So I'm going to put a negative sign and a bracket around negative 29x squared minus 87x, which is this. I'm going to find a difference. And once again, negative 29x squared is gotten rid of. The term with the highest degree is gotten rid of. And actually that's the purpose, because we want to get rid of the highest degree step by step, just like the case for numbers, whereby we get rid of a number, then we move on to another number by bringing down another number into the long division. So I get 90x plus 6. And now this is the term. The 90x is the term with the highest degree. So I'm going to focus on 90x now. And I'm going to multiply over here to x plus 3 to get rid of the 90x. In this case, I'm going to multiply 90. So 90 times x plus 3, I'm going to get 90x plus 270, and again put negative sign and brackets around 90x plus 270 to find the difference, and I get negative 264. And with this, right, I ask myself, can I still multiply some algebraic term over here, so that when it's multiplied x plus 3, and I can get rid of negative 264? Answer is no. I'm going to stop here actually, because now, right, this negative 264, the degree, is smaller than that of the divisor. The divisor is x plus 3, it has a degree of 1. So I'm going to stop here. So if I compare this situation with the situation of the numbers, we actually stop just now because the value 2 is smaller than that of the divisor. But for polynomials, we don't have values to talk about at the moment, so we are just considering the degrees. So when the degree is smaller than that of the divisor, we're going to stop. And so with this, we can conclude that the remainder when ax cubed minus 5x squared plus 3x plus 6 is divided by x plus 3 is negative 264.